Hello, welcome to this session on proof by contradiction. I'm just going to go through an example. I'm going to prove by contradiction that if n squared is even, then n must be even. And I think this is something we kind of know through experience and I suppose intuition, the feeling for numbers, but it's also something we really at times need to prove. It was, I think, the great philosopher Martin Harris who said, knowing is not necessarily understanding, and proof really tests those skills of understanding. Now, I'm going to show you how to structure a proof such as this. So first of all, we assume that the opposite is true. So I'm going to say, assume that there exists a number such that a number n, I should say, there's a number n such that n squared is even, but n is not even. So that's your first step, really. I'm assuming the opposite. I'm making an opposite assumption. Well, let's see how this pans out. If n is not even, then n is odd. So we know n is odd. So we can say, okay, if n is odd, let n equal 2k plus 1. 2k plus 1 because it's an even number, plus 1. An odd number is an even number plus 1. This is where k is some integer. There you go. So what happens then if that's the case? I'm going to square n. Well, n squared would be, in this case, 2k plus 1 squared. I'm committing a bit of a sin there by doing a couple of equal signs there on the same line, but let's live life dangerously. 4k squared plus 4k plus 1. Well, I could write that as 2 lots of 2k squared plus 2k with a 1 on the end. Now, that's obviously 2 times a number, an even number, plus 1. And it's odd, which is odd. Now, why is that important? It contradicts. It contradicts the assumption. This contradicts the assumption that n squared is even. And finally, seems a bit long-winded, but I want to be as thorough as possible. Therefore, if n squared is even, then n must be even. We know that because we've shown if n is odd, we square it, we certainly get an odd number. Let's just have a look through that. There's what I'm trying to do. There's my assumption. I'm using modelling an odd number as 2k plus 1. And I'm showing the algebra what happens when I square an odd number as 2k plus 1. I state my contradiction and then I just make my final statement. Seems a bit long-winded, but it's thorough. It shows all the steps and that would get full marks. And this proof itself is something that might be allowed to be assumed in another proof that you will see in another video, where if you know n squared is even, n is even. Okay, I hope that is clear. Thank you.